Hello everyone there. Welcome back to JYOTSNA'S Colorful Chemistry. So in today's class, we are going to deal about the next method of preparation of aldehyde, that is from aromatic hydrocarbons. So from the aromatic hydrocarbons, there are several methods. So let us take a look of the first method. First method is by the oxidation of methyl benzene. Methyl benzene is also called as toluene. In this one, the first reaction which we are going to study is Etard's reaction. So as it is a named reaction, hence it is an important reaction. So in this Etard's reaction, what we are going to do is, we are going to take chromyl chloride. So this chromyl chloride, CrO2Cl2, this chromyl chloride is going to oxidize this toluene. Toluene is C6H5CH3 or methyl benzene. So when we are going to take this chromyl chloride in carbon disulfide and treat it with toluene, these are going to react and lead to the formation of a chromium complex. After the chromium complex is formed, it is undergoing hydrolysis and it leads to the formation of the benzaldehyde. So here what is going to happen, you can just take a look here. Out of these 3 H, 2 of the H combines with this one. So this product is going to come over here. You can see here CH into bracket. This is CrO2, this is CrO2, and this 2H comes inside and we have Cl2. The whole we are going to write for twice. So this is an intermediate complex which is going to form, which is undergoing further hydrolysis to lead to the formation of the benzaldehyde. The byproducts obtained are not shown over here. So this is called as the Etard's reaction. Since it is a named reaction, it is an important reaction. Our next reaction is by making use of chromic oxide, that is CrO3. Here also we are taking toluene. So toluene is converted to benzalidene diacetate on treating it with chromic oxide in acetic anhydride, which is further hydrolyzed to benzaldehyde with aqueous acid. So let us take a look of this reaction. So here, this is toluene. When we are going to treat it with chromic oxide in acetic anhydride, this reaction takes place between 273 to 283 Kelvin, and the product obtained here is benzalidene diacetate, that is C6H5CH into bracket OCOCH3 twice. So this is a compound, intermediate compound formed, which further undergoes hydrolysis and it leads to the formation of the benzaldehyde, that is C6H5CHO. So in this way, by making use of the chromic oxide, we are going to convert this toluene into benzaldehyde. So this is the second method starting from the aromatic hydrocarbon, for example methyl benzene or toluene. Coming to the next method, that is the commercial method of preparation of the benzaldehyde. Now in the commercial method, that means when you are going to manufacture it in the large scale, we call it as the commercial method. So in the commercial method of manufacture of benzaldehyde, we are going to do the side chain chlorination of the toluene to give the benzyl chloride, which on further hydrolysis gives benzaldehyde. So this is toluene. When we are going to pass this chlorine in presence of H nu, that is the sunlight, here side chain chlorination takes place. So the chlorination does not take place at the benzene ring, but side chain means to this methyl group. Here this chlorination is going to take place. So out of these 2 hydrogen is coming out and 2 Cl are getting introduced over here. So it leads to the formation of C6H5 CHCl2, that is called as benzyl chloride. So side chain chlorination takes place. Further, this benzyl chloride is undergoing hydrolysis at about 373 Kelvin and leads to the formation of benzaldehyde, that is C6H5CHO. This method is the manufacturing method of the benzaldehyde, and these are some of the methods of preparation of the aldehyde, that is the benzaldehyde or the aromatic aldehydes, starting from the aromatic hydrocarbons. Next to that one, we have one more important reaction. This is named by the Gatterman-Koch reaction. Because it is again a named reaction, it is an important reaction. So in the Gatterman-Koch reaction, what is done is, we are going to take benzene. So this benzene is passed with, it reacts with carbon monoxide and hydrogen chloride in presence of anhydrous AlCl3 aluminum chloride or cuprous chloride like CuCl to form the benzaldehyde. This is just one step reaction. Benzene is the reactant, product is benzaldehyde, and in between you have what? The reactant like carbon monoxide and hydrogen chloride. And this reaction takes place in presence of what? Anhydrous AlCl3 or CuCl. So this leads to the formation of the benzaldehyde. So this is called as the Gatterman-Koch reaction. Next to that one, we have the methods of preparation of ketones. So till now we have seen the aldehydes preparation. So now let us take a look of preparation of the ketones. Now coming to the preparation of the ketones, the first method is from acyl chloride. So when we are going to treat this acyl chloride with dialkyl cadmium, so when we are going to treat it, it leads to the formation of the ketone. So what is this acyl chloride? Let us take an example, that is RCOCl. So this is an acid chloride, or we call it as the acyl chloride. So here this acid chloride reacts with dialkyl cadmium, leads to the formation of the ketone. So what is happening here is, whatever the Cl is there, that is being replaced by the alkyl group, and therefore it leads to the formation of ketone, and CdCl2 cadmium chloride is obtained. This dialkyl cadmium, how is it obtained? This dialkyl cadmium is obtained by the reaction of cadmium chloride with Grignard reagent. So Grignard reagent, as you know, it has a general formula of RMgX. So this reacts with cadmium chloride CdCl2 and leads to the formation of the dialkyl cadmium. So this dialkyl cadmium, we are getting it here, and this dialkyl cadmium, we are going to make use of it for the reaction purpose. How this is obtained is given in this note. So what is happening? Acid chloride reacts with dialkyl cadmium and leads to the formation of what? Of ketone. So this is how we have the one of the method of preparation of ketone. Now let us go for the next method. Our next method is Friedel-Crafts reaction. So this is an example of acylation reaction. So already you have come across Friedel-Crafts acylation reaction. So let us take a look of it once more. Here we are going to take benzene. So this is our benzene. So benzene, when we are treating it with acid chloride, that is RCOCl. So R can be methyl group, ethyl group, and so on. So CH3COCl you can take, or any other example. So benzene reacts with acid chloride in presence of anhydrous AlCl3. As you remember, Friedel-Crafts reaction, necessarily anhydrous AlCl3 has to be used as the catalyst. So during this, acylation takes place. So here one of the H combines with Cl, forms HCl. In that place, RCO is being introduced. So therefore you can see that this is C6H5CO and R. So this is nothing but it leads to the formation of the ketone. So then let us go for the next method. Coming to the next method, we have next method is from nitriles. So nitriles are nothing but cyanides. So when we are going to take the nitrile and we are going to treat it with Grignard reagent, which is followed by the hydrolysis, it leads to the formation of the ketone. Now let us take an example of propane nitrile. Propane nitrile, 3 carbon atoms consisting of a nitrile group. So CH3, CH2, C triple bond N. Propane nitrile, when we combine it with Grignard reagent, here as you remember, Grignard reagent general formula is RMgX. Here we have taken phenyl group for R and X we have taken as bromine. So it is phenyl magnesium bromide. When we are going to treat this one in ether medium, out of this triple bond, one of the bond is going to break, and to this N, this MgBr is going to combine with, and this C6H5 combines with this carbon. So it leads to the formation of the compound CH3CH2C double bond NMgBr and single bond C6H5. This one is further undergoing hydrolysis and leads to the formation of C2H5 CO C6H5. So whatever this portion is there, this is going to lead to the formation of what? It forms the ketone, and this is going to come out, and on hydrolysis what happens? C2H5CO C6H5. So here what is going to happen is we are going to call this one as propiophenone. This is called as a propiophenone, or in this case what you can take? You can take these three as a parent chain, so that is nothing but a propanone, and to that one on the first carbon you have the phenyl group attached, so you can call it as 1-phenyl propanone, or the common name is what? Propiophenone. So in this way it leads to the formation of a ketone. Along with that we have the side chain, the byproducts obtained, that is MgOH and Br, and NH3 has been obtained. So in this way it leads to the formation of the ketone. So these are few methods of preparation of aldehydes and ketones.